The first thing I'll show is the heavyweight callback monitoring that's been added. I have one DataSnap server that I've created. So it just looks like this, and then what it's going to do, it's going to be showing you the clients that are connecting heavyweight callbacks, and it allows you to write a message to the clients. There's another client here, and this is written using the client callback channel manager component, which uses a TCP connection and connects to the server on port 211, and it uses heavyweight callbacks. And this first block here, you can create one callback and it will get the messages broadcast from the server, and down here you can create a second callback. This button allows you to stop all callbacks and disconnect the client from the server. And what this example is going to show is when I push the button, I'm not changing the button enablement at all. I'm adding this event on channel state change. And in the event, I'm kicking it off a thread to run in the UI thread later that will change the button enablement based on the event that just happened. So for example, if a callback has been added to the server, for example, if it was the first callback here, if you click start, the first callback is going to be added to the server. You're going to get an event saying a callback's been added to the server with this ID. The event checks the ID, and if it's the first callback, it knows to disable this button and enable this button, because you're then going to be able to stop the callback. You can't start it when it's already been started. So what we're doing here is we're using events to control the UI instead of hard coding the button enablement changes into the button click. And you can use this to do whatever you want. For example, if I then close the server's going to kill the heavyweight callbacks, but now the client knows this is happening in an easy way because it's listening with the event, and it will be able to disable these buttons and just put back the start buttons because it knows that it's been killed. Before you had these events, it might not be so easy to know that the server had killed your connection. You'd have to hard code in something into your callbacks to catch that. I also have the other client also written in Delphi, but this one is using a REST connection, and internally it's creating an instance of REST client channel, and on this it's also setting the on channel state change. So you can see here again it's update button enablement, and again it's creating this UI thread, and it's going to be changing the button enablement. So it's just things like if channel is created, you're saying that a callback has been added. Likewise, if another callback's been added, you're saying update the button enablement, same callback. You're getting the callback ID, which is from the event item, callback ID. So event item has a few things in it. It has the callback ID, the ID of the callback being added or removed, and it has the tunnel ID, which is the ID of the tunnel being acted on. And the only time it doesn't have callback ID is if the tunnel is being closed. So if a tunnel is being created, it needs to be created with a single callback. You can't have a tunnel without at least one callback. So when the event type tunnel created will have a callback ID and a tunnel ID. The event callback added will have both of those again, tunnel ID and callback ID. And callback removed, again, will have those three, tunnel ID and callback ID. If the tunnel has been closed, it will just have the tunnel ID and callback ID will be empty string. So this just handles those cases and changes the button enablement depending on what's happened. And both of these implementations are virtually identical for these two clients. And the last client we have is the JavaScript REST client. So if I show you the contents of the directory again, you'll see there's a web directory, and there's an index.html file, and there's JavaScript file. I have them both open here. So the HTML file just creates text areas similar to the other clients I showed you, and it calls on the on-click button on start and stop, it calls various JavaScript functions. And the JavaScript is in this file here. So you can see at the beginning it's creating a client channel, which in terms of the thick clients would be called a tunnel. In thin clients or REST clients it's called a channel. And it's calling on channel state changed and adding a function event here. So it's creating some callbacks, and it registers the callbacks when you click the start buttons, and it unregisters them when you click the stop buttons. You can see that handle channel event handles all the different events that are possible. So there's these event types: channel start, channel stop, callback added, callback remove, and disconnected by server. So again, this is just handling the button enablement, and it changes the states to disabled or enabled. And that's all. And also in the callbacks themselves, it will set the message to the memo that's sent by the server. So all these clients do essentially exactly the same thing, but you're setting the event that you're using to listen for heavyweight callback changes in a slightly different way for each client. So I'm just going to go ahead and run these now so you can see them working. I'm going to run the server first, and I'm going to run each of the available clients. And I'm going to go back to the server, and I'm going to hit open in browser so I can have all of these running at once. And I'm going to hit start. So when you see me hit start the first time, you'll see a tunnel was created because the callback's being added, and it's the first callback, so it creates the tunnel. Now there's the connection between the server and the client, and it's saying a callback was added, and it tells you the ID of the callback. Now if I click start with this one, the tunnel's not created again, it's using the same tunnel. And a second callback was added with ID callback 2. Now I'm going to do this again with the other client, the REST client, and again you're going to see a tunnel was created and a callback was added and another callback was added. Going to the browser, you're going to get the exact same thing. A tunnel was created, a callback was added. So these are all doing exactly the same thing, sending the same events. And if you noticed, while I was doing this, all of the button enablement was being done for me through the event. So when I hit a button, like this for example, now you can see here, a callback was removed. And so this is the server event being fired. The client event being fired in this case changed the button enablement. Stop is now disabled, start is now enabled. So it knew, okay, the callback has been disconnected. I'm going to let them start it again if they want. So now it's enabled again and allowed me to register it again. You can stop all of the callbacks, and you can see a tunnel was closed, or you can kill the server. And now you see on the clients that the start buttons are enabled. For these, they know the server's gone down, they know their heavyweight callbacks have been terminated. So that is a very quick example of the heavyweight callback events that have been added in this monitoring theme that allow you to keep track of what's going on the server. The next thing, still on the monitoring theme, is the monitoring for TCP connections. In your DataSnap server, you can keep track of when TCP IP connections are created with your server and when they're closed. Also, you can control how long they stay connected. You can boot a connection at any time you want, or you can use keep alive settings to say if the client is inactive for so long, send a keep alive packet, and if they don't respond to that after so many retries, disconnect them and their session is closed with the server. So I have the server and the client here to show you this. I'm just going to run the server and run the client. And I have this program to do a few things. One, I have it to just connect to the server and constantly call reverse string. It's keeping track of the requests it sends to the server, and the server is set to boot the user automatically if it sends more than 50 requests in 1 minute. So if we let this go, we might find that it hits 50 before a minute. Or you can also right click and you can see that it knows the TCP IP connection and the port it's connecting from, as well as the session that corresponds with that. You can also choose to close the connection here, and you'll see that it closes the connection. It only got the 30 requests and the start button's been enabled. Now if I want to make this a little faster, to every 100 milliseconds send a request, you're going to see it's going faster. It's getting up to almost 50 now, and when it gets to 50, you can see the connection's booted. And this is the authentication manager on the server coded in a way that just says, okay, you've hit 50, I'm booting you. Now they can just connect again unless you want to keep track of their IP address somewhere in your server, and then the authentication manager, just take note of that. Say this is a temporarily banned IP address, for example. Don't allow them to connect on the on-user authenticate event. There's another situation that comes up, and that's where the client loses its connection. Maybe the Ethernet cable comes undone, maybe their connection to the internet is disrupted abruptly somehow. And you get a lot of these ghost or dead connections because the server isn't sending anything to the client. It doesn't know that there's no one there. So let's just close this and bring up a VM I have here. And it's connecting to my server, and it's just going slowly back to the server, sending those requests. And I see it's connected here. But what I want to do is I'm going to enable Keep Alive and say if the connection is down for more than 2 seconds, like if there's no reverse string requests being sent in this case, wait 2 seconds and then use the operating system's keep alive setting to check if it's still there. So now I'm just going to right click and go enable keep alive. It's going to use the settings here. And what I'm going to do is I'm going to go to the VM and I'm going to kill the network adapter. Disconnecting, and you'll see here after a couple seconds this goes away. And that's because the keep alive sent packets, they were not answered by the client, so it killed the TCP connection. And so I'll just show you a little bit of the code in here so you can see how it's being done. So if I go to the server project here, you can see here it's just adding the TCP IP connection. It needs to cast it from event.connection because in this event it's just stored as t-object to prevent any linking issues. It can be a different connection if you want, but for all intents and purposes it's going to be this indie connection. And it also has the channel. In this dictionary we're storing both of them, and then on disconnect we're removing them from the dictionary. So you can see that here it's deleting it. And the channel is what has the close method on it. So if you wanted to kill a TCP connection, you would get the channel and you know what connection it's associated with, and then you just call close on it, and that's going to close the channel and kill the connection. And this is how you keep track of it as well, by storing it in the map yourself. There's no API for saying get me all of the available TCP connections. It's up to the server implementation to do that. So the other thing to show you with the server is the implementation of the authentication manager, and there's nothing much new here, so I'm not going to spend much time on it, but if we go to the authentication manager, it just has authorize implemented, not the authenticate. And it's just keeping track of, there's the elapsed seconds and everything. So these are the properties you see in the top of the server dialog. And then it's just going to wait to see if it needs to close it or not. And if it does need to close it, it goes into the force close connection. It gets the connection list object, and then it gets the channel for that TCP IP connection, and then on the channel it calls close. Similarly, if you call close selected, it gets the selected channel and it calls close on it. So that's all there is to the TCP connection monitoring, but it allows you to do things you couldn't in previous versions of DataSnap. It allows you to keep track of all the connections and to kill any connection you want, or to have it automatically disconnected and maybe even temporarily banned if it does anything that the server doesn't like.